The National Electrical Code, or NEC, does not explicitly address the requirement for GFCI protection of drinking water fountains. However, GFCI protection is generally required for receptacles and equipment that are located outdoors or in areas with a high risk of electrical shock, such as bathrooms and kitchens. A National Electrical Manufacturers Association, or NEMA, develops industry standards for electrical equipment, and they recommend that GFCI protection be provided for any receptacle or appliance that is located outdoors or within 6 feet of a water source. This recommendation is based on the potential for electrical shock if the receptacle or appliance comes into contact with water. While the NEC does not specifically require GFCI protection for drinking water fountains, it is highly recommended to provide GFCI protection in accordance with NEMA's recommendation. This will help to reduce the risk of electrical shock in the event of a water leak or other malfunction. Additionally, many local building codes and electrical codes may require GFCI protection for drinking water fountains. It is always best to check with your local authorities for specific requirements. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit. If there is a difference of 5 mA or more between the current flowing into the circuit and the current flowing out of the circuit, the GFCI will trip, cutting off the power to the circuit. This happens very quickly, typically in a fraction of a second, preventing a dangerous electrical shock. GFCIs are required by the NEC in many locations, including bathrooms, kitchens, garages, and outdoor areas. The purpose of these requirements is to reduce the risk of electrical shock in areas where people are more likely to come into contact with water or other conductive materials. While the NEC doesn't explicitly mandate GFCI protection for drinking water fountains in all cases, the proximity of water and the potential for users to be barefoot or have wet hands makes it a location where GFCI protection is highly advisable. The NEMA recommendation of providing GFCI protection for any receptacle or appliance located outdoors or within 6 feet of a water source further supports this practice. When considering GFCI protection for a drinking water fountain, there are several factors to keep in mind. Firstly, consider the location of the fountain. Is it indoors or outdoors? Is it located in an area where people are likely to be wet, such as a swimming pool or splash pad? Secondly, consider the type of fountain. Is it a self-contained unit or is it connected to a water supply line? Thirdly, check with your local building codes and electrical codes to see if there are any specific requirements for GFCI protection of drinking water fountains in your area. If you are unsure whether or not to provide GFCI protection for a drinking water fountain, it is always best to err on the side of caution and install a GFCI. This will help to ensure the safety of people who use the fountain. There are several types of GFCIs available, including receptacle GFCIs and circuit breaker GFCIs. Receptacle GFCIs are installed in place of a standard electrical outlet and provide GFCI protection for anything plugged into that outlet. Circuit breaker GFCIs are installed in the electrical panel and provide GFCI protection for an entire circuit. When choosing a GFCI, it is important to select one that is rated for the appropriate voltage and amperage. It is also important to choose a GFCI that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or OL. Installing a GFCI is a relatively simple process, but it is important to follow the manufacturer's instructions carefully. If you are not comfortable installing a GFCI yourself, it is best to hire a qualified electrician. In addition to GFCI protection, it is also important to ensure that the drinking water fountain is properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, which helps to prevent electrical shock. The grounding conductor should be connected to the metal frame of the fountain and to the grounding electrode system of the building. Regular inspection and maintenance of drinking water fountains are also essential for electrical safety. Check the fountain for any signs of damage, such as cracks, leaks, or exposed wires. If you find any damage, have it repaired immediately by a qualified technician. Also, test the GFCI regularly to ensure that it is working properly. Most GFCIs have a test button that you can push to simulate a ground fault. When you push the test button, the GFCI should trip, cutting off the power to the circuit. If the GFCI does not trip, it may be faulty and need to be replaced. Remember that even with GFCI protection, it is still important to exercise caution when using electrical equipment near water. Avoid touching electrical equipment with wet hands, and never use electrical equipment that is damaged or malfunctioning. By following these safety precautions, you can help to prevent electrical shock and ensure the safe operation of drinking water fountains. Ultimately, the decision of whether or not to install a GFCI for a drinking water fountain involves a careful assessment of risk, code requirements, and best practices. While the NEC provides general guidelines for GFCI protection, it is important to consider the specific circumstances of each installation and consult with local authorities to ensure compliance with all applicable codes and regulations. Furthermore, staying informed about the latest recommendations from organizations like NEMA and industry best practices can help ensure the highest level of electrical safety for drinking water fountain users. The goal is always to minimize the risk of electrical shock and create a safe environment for everyone. Firstly, consider the specific installation environment. Is the drinking fountain located indoors in a controlled environment, or is it outdoors, exposed to the elements? Outdoor locations present a greater risk of electrical shock due to moisture and environmental factors. Secondly, assess the likelihood of water exposure. Is the fountain prone to splashing or leaks? Are users likely to have wet hands when operating the fountain? The greater the potential for water exposure, the greater the need for GFCI protection. Thirdly, consult with local building and electrical codes. These codes may have specific requirements for GFCI protection of drinking water fountains, regardless of the NEC explicit language. Fourthly, consider the users of the drinking water fountain. Are they primarily adults or children? Children are more vulnerable to electrical shock due to their smaller body size and lower resistance. Fifthly, evaluate the overall condition of the electrical wiring and equipment associated with the drinking water fountain. If the wiring is old or damaged, the risk of electrical shock is increased. Sixthly, implement a regular inspection and maintenance program. This program should include periodic testing of the GFCI to ensure that it is functioning properly. Seventhly, document your decision-making process. Keep a record of the factors you considered and the rationale behind your decision to install or not install a GFCI. This documentation can be helpful in the event of an incident or inspection. Eighthly, provide clear signage near the drinking water fountain to warn users of potential electrical hazards. Ninthly, train personnel who are responsible for maintaining the drinking water fountain on proper electrical safety procedures. Tenthly, stay up to date on the latest electrical safety standards and best practices. The electrical industry is constantly evolving, so it is important to stay informed about the latest developments. Remember that GFCI protection is just one layer of safety. It is also important to ensure that the drinking water fountain is properly grounded and that all electrical connections are secure. By taking a comprehensive approach to electrical safety, you can help to minimize the risk of electrical shock and create a safe environment for everyone. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC is a comprehensive document that covers a wide range of electrical safety topics, including grounding, wiring methods, overcurrent protection, and equipment installation. It is essential for anyone who works with electricity to be familiar with the NEC and to follow its requirements carefully. In addition to the NEC, there are also a number of other organizations that develop electrical safety standards, such as the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI. These standards provide guidance on a variety of electrical safety topics, including grounding, bonding, surge protection, and arc flash hazards. It is important to be familiar with these standards and to follow their recommendations when working with electricity. Grounding and bonding are two important concepts in electrical safety. Grounding provides a path for fault current to flow back to the electrical panel, which helps to prevent electrical shock. Bonding connects all of the metal parts of an electrical system together, which helps to equalize the voltage and reduce the risk of electrical shock. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage electrical equipment. Surge protectors help to protect electrical equipment from surges by diverting the excess voltage to ground. Arc flash is a dangerous phenomenon that can occur when there is a short circuit in an electrical system. Arc flash can cause severe burns, blindness, and even death. It is important to take precautions to prevent arc flash, such as wearing appropriate personal protective equipment, or PPE, and following safe work practices. Electrical safety is a critical concern in all aspects of life, from residential to commercial and industrial settings. Understanding and adhering to the National Electrical Code, or NEC, along with recommendations from organizations like the National Electrical Manufacturers Association, or NEMA, is paramount for ensuring the safety of individuals and preventing electrical hazards. When it comes to drinking water fountains, the NEC doesn't explicitly mandate GFCI protection in every scenario. However, the presence of water and the potential for contact with electrical components create an environment where GFCI protection is highly advisable. GFCIs, or ground fault circuit interrupters, are designed to detect even small imbalances in electrical current, quickly cutting off power to prevent electrical shock. NEMA recommends GFCI protection for receptacles and appliances within 6 feet of a water source, a guideline that strongly supports the use of GFCIs for drinking water fountains. Local building codes and electrical regulations may also have specific requirements for GFCI protection of drinking water fountains, so it's crucial to consult with local authorities to ensure compliance. Furthermore, it's important to consider the location of the drinking water fountain. Outdoor installations are exposed to the elements, increasing the risk of electrical hazards due to moisture. Indoor locations, while seemingly safer, can still present risks, especially if the fountain is near other water sources or in areas where people may be barefoot or have wet hands. The type of drinking water fountain also matters. Self-contained units may have different electrical requirements than those connected to a water supply line. Regularly inspecting and maintaining drinking water fountains is essential for identifying potential electrical hazards such as frayed wires, loose connections, or water leaks. Any such issue should be addressed promptly by a qualified electrician. In addition to GFCI protection, proper grounding is crucial for electrical safety. Grounding provides a path for fault current to flow back to the electrical panel, reducing the risk of electrical shock. All metal parts of the drinking water fountain should be properly grounded. Safety signage near the drinking water fountain can also help to alert users to potential electrical hazards. Training personnel responsible for maintaining the fountain on electrical safety procedures is also essential. Regular testing of GFCIs is vital to ensure they are functioning correctly. Most GFCIs have a test button that simulates a ground fault, allowing you to verify that the device strips and cuts off power as intended. If a GFCI fails to trip during testing, it should be replaced immediately. Staying informed about the latest electrical safety standards and best practices is an ongoing process. The electrical industry is constantly evolving, and new technologies and safety measures are always being developed. By prioritizing electrical safety in the installation, maintenance, and use of drinking water fountains, we can help to protect individuals from electrical hazards and ensure a safe environment for everyone.